Lesson 6-2, Volume of Prisms and Cylinders. We're going to cover this unit in just 2 lessons. Today we're going to talk about prisms and cylinders, which are a review from 7th grade. And then our next lesson we'll talk about the volume of cones and spheres, which will use formulas that you can find on your reference sheet. For the volume of prisms and cylinders, we use the same formula from 7th grade, volume equal base area times height. Notice that the B is capitalized. That is because it is not a single dimension length. It is an area of the base shape. And then H is for the height between the 2 bases. When we have a prism, then it has 2 bases that are equally shaped, and the height's the distance between those. In a cylinder, we have 2 circles that are equally shaped, and the height is the distance between those. In our example, we're going to find the volume of each figure to the nearest tenth, and we'll use 3.14 for pi. If it doesn't specify to use 3.14 for pi, then you can use a pi button in your calculator, or sometimes it may even ask you to leave your answer in terms of pi, where you just leave pi throughout the entire problem. Part A, we have a rectangular box with a base 2 centimeters by 5 centimeters and a height of 3 centimeters. We could start by drawing a picture to describe this. So we have a rectangular box, which is also called a rectangular prism, and it's got a base of 2 centimeters by 5 centimeters. That appears to be this top portion here, and a height of 3 centimeters. So our base would be the top and the bottom because there's 2 equal bases on opposite sides, and so the height's the distance between those. So we'll start with our formula. Then we'll plug in the base area. In this case it's a rectangle, so that would be length times width, and then multiply by the height. And we'll just plug all of those values in. Our base is 5 by 2, and then the height is 3. We don't have to keep using a parenthesis here since this is all going to be multiplied. And we just multiply and get 5 times 2 is 10, times 3 is 30, cubic centimeters. Because there were 3 dimensions, our volume is going to be measured in cubic units. And we're finished. B part. We have a can of nacho cheese with a radius of 3 inches and a height of 8 inches. So we'll start by drawing a picture. And after drawing your picture, you can go ahead and go to the formula. Volume equal base area times height. In this case, our base area is the area of a circle. So the area of a circle is pi r squared. Then we multiply by the height of the cylinder. And so when we plug in, we've got 3.14 times 3 squared times 8. Now I just continue to simplify. 3 squared is 9. And then we just multiply all the way through and get 226.1 cubic inches, rounded to the 10th place. Part C, we have a composite figure. It's made up of a rectangular prism that has a triangular prism stacked above it. Notice that it gives you all the dimensions that are necessary to find the volume. Now to find this volume, we're going to combine these 2 separate volumes of these 2 figures. So we're going to add the volume of the rectangular prism to the volume of the triangular prism. We'll start by writing the formulas. Notice that the formula for volume of a triangular prism uses the triangle volume, or the triangle area formula, that A equal 1/2 base times height, and that's found on your reference sheet. You don't have to have that memorized, but do be careful because we have 2 different references to height on the triangular prism. The first is the height of the triangle, the second is the height of the prism. So looking at these and plugging them in, for this rectangular prism, I am going to use the front of this as my base. So length times width would be 6 times 5, and then the height would be the distance going back, which is 9. That would be the distance between the front and the back of this rectangular prism. For the triangular prism, I'm going to use the triangle. Oops. We use the triangle here. Hard to tell a difference in those. So we have that triangle area on the front of the prism, and there is a triangle on the back of the prism that you don't see. And so we just use the formula 1/2 times the base, which is 6, times the height, which is 3, and you can tell that they meet at 90-degree angle right here. So that allows us to use those as base and height of the triangle. Then times the height of the prism, which is the distance between the front and back triangles, which is 9. And so then we just simplify those. 6 times 5 times 9 is 270. And then 1/2 times 6 is 3, times 3 is 9, times 9 is 81. And added together, we get 351 cubic centimeters.